Hi there. Today we're going to be talking about the circulation of blood. This has very little to do with the actual heart itself and how the heart works. We're going to talk about the freeway that blood travels, the arteries, capillaries, and veins and their structure. So let's first talk about how arteries and veins are put together. So there are three types of blood vessels I just mentioned: arteries, veins, and capillaries. Arteries always carry blood away from the heart. We don't focus on whether or not that blood contains lots of oxygen or not. Arteries just carry blood away from the heart. Veins carry blood toward the heart. Okay, again, oxygenated and deoxygenated content is not important here. The reason why we say that is because sometimes you have, at least between the circulation between the heart and the pulmonary system, the veins and the arteries carry the opposite of what you would think. Arteries carry deoxygenated blood away from the right ventricle to the lungs for charging, right? So that's an artery. The blood's being carried away. It's not a vein, and it contains deoxygenated blood. So when we're defining blood or vessel type, it's always defined on the direction of blood from or to the heart, not degree of oxygenation. Now, capillaries lay between arteries and veins. They actually lay between what we call arterioles and venules. These are smaller arteries and veins that have slightly different structure. And what capillaries do, is allow gas exchange to occur in tissues. So the things I want to focus on right now are going to be the arteries and the veins. Oh, excuse me. I got up early this morning. Okay, so within arteries and veins, we have three what we call tunics or layers. The tunica intima is always the internal layer here, which is made up of endothelial cells. Endo for internal, right? Thelial, T-H-E. Endothelial cells are just basically squamous epithelial cells. It's just they're called endothelial cells because they're on the inside of the entire vessel. So tunica intima is in the very internal of a blood vessel. Tunica media, right here, is made up of smooth muscle. I'll just put SM here for smooth muscle. And you'll see that arteries have more tunica media than veins do. And then the tunica externa is just connective tissue, and you can see this here in the label. But the connective tissue, which surrounds the media and interna, and they're about the same between arteries and veins in terms of density and thickness. Oh my goodness, I need to drink more coffee. So let's start with arteries. The tunica intima is, again, made of these internal endothelial cells that are held together by basement membrane. This is a region where gas, if there was no tunica media or externa, could escape, could exchange between tissues and vessels. But since arteries are freeways, right? Freeways don't have a whole lot of off ramps. You'll go from an artery to an arterial, which is like the freeway off ramp. But the artery itself does not allow gas exchange to occur, okay? The tunica media, smooth muscle, very thickened arteries, and what this area is doing, what the tunica media is doing, is controlling blood pressure. So if blood pressure is low, the tunica media will contract a little bit to make the artery a little bit more narrow, increasing blood pressure. If blood pressure is high, the tunica media can relax to bring blood pressure back down. So remember, contraction increases blood pressure, okay? At least contraction of the tunica media. The tunica externa, again, is a layer of elastic tissue, connective tissue. It's relatively thin, but it's strong enough to hold the whole structure together. The capillaries, again, are just microscopic vessels, made up only of tunica intima. So if you think of a capillary bed is basically an artery or vein stripped of tunica media and intima. It's just tunica media and externa. It's just the tunica media. Intima. Oh my goodness. I need to wake up later. Holy cannolis. I can't believe how sleepy I am right now. I usually get up early, you guys, so I can go for a run, but I didn't go for the run. Maybe it's the run I need. Okay, let's go back to blood vessels, veins. Tunica intima, again, is that internal layer. The difference between a vein and an artery are these valves. The valves always allow one-way circulation, right? I should have started farther over. What that means is that blood will only flow in this direction towards the heart. And that's important because there's not a lot of blood pressure in a vein. We'll get to that in a little bit. The tunica media over here, also smooth muscle, but it doesn't have as much smooth muscle as an artery. So this doesn't control blood pressure so effectively. Veins are low blood pressure blood vessels. Arteries, on the other hand, are high blood pressure vessels, okay? So by the time you get to a vein, there's very little blood pressure. Therefore, you don't really need a whole lot of tunica media to help regulate blood pressure. Tunica externa externa is again this heavy connective tissue on the outside. Oh my gosh, now I have tuna externa. Oh my goodness. Tunica. Seriously, I did go to graduate school, you guys. Maybe I just need to go for my run first. Okay, what are the functions of each vessel? The arteries, of course, are going to help to distribute nutrients, gases, and everything else by moving the blood away from the heart under high pressure to tissues, moving it to capillaries. So arteries take blood to capillaries, okay? And arteries maintain blood pressure, all right? And why is that? Because that tunica media, all right, that tunica media, that thick layer of connective tissue. Capillaries serve to exchange as exchange vessels for nutrients, waste, fluids. This is where gas exchange happens. Now, in addition to gas exchange, it's also nutrient exchange, waste exchange, and fluid exchange. All right. So blood goes from arteries to capillaries, from capillaries to veins. And remember, in capillary beds, you don't want the blood to come out, the red blood cells. The formed elements, for the most part, the red blood cells at least, need to stay in the capillaries. White blood cells can escape out, but we'll talk about that in the lymphatic system chapter. Now, veins collect blood from the capillaries to return it back to the heart, but it goes back under low pressure. So what you're seeing here in terms of pressure is a situation where you start with high pressure and you go to low pressure. In fact, the pressure drop happens between arteries and capillaries, and we'll talk about that in a few minutes. Now, what can happen to a blood vessel that would make the vessel, I guess you would say, sick? Okay, what's a disorder of an artery? Arteries themselves have to withstand, like we said, lots of high pressure, right? That high pressure is important because it allows blood to basically be ejected out into the body. Why does the high pressure happen? I need more high pressure. Holy cow. The high pressure occurs because the left ventricle is pumping blood out. So the high pressure is necessary to get the blood out to the body, right? So that high pressure also helps blood vessels remain free of blockage. So high pressure is necessary to get blood out to the body and to keep blockages from happening. Now, what happens if you do end up with a disease of pressure? Well, that's called arteriosclerosis. Sclerosis means scarring, actually, okay? Arterio means artery, and that's the hardening of the arteries. Now, this is going to happen regardless of what your diet is, what your exercise status is throughout your life. As we get older, everyone will undergo some degree of arteriosclerosis or hardening of the arteries because as time goes on and our body keeps pumping blood, the arteries, the aorta and the initial arteries coming off of the aorta, like the carotid and so forth, have gone through many, many years of expansion and distension, okay? That just means they're getting stretched out to some degree, all right? So that arteriosclerosis reduces the amount of blood flow going to parts of the body that can cause ischemia, or ischemia just means that blood's not effectively flowing somewhere. Ischemia eventually turns to necrosis or cell death, cell deterioration and death, and eventually it can lead to gangrene, especially in terminal parts of the body, very distal parts of the body from the heart, like the toes. Arteriosclerosis happens just as a consequence of aging, as I mentioned. How do we keep that from really affecting us? Well, you just got to keep moving. There are medications that help treat arteriosclerosis, and what they do is they help regulate blood pressure. So what happens is, because the blood vessels, the arteries, become hardened, blood pressure is not regulated properly, and that's what leads to a reduction in blood flow. Sometimes you'll also end up with atherosclerosis. This should have been over here and in blue. This is where lipids and other stuff might clump up and block the arteries. Atherosclerosis is very common in individuals with a Western diet. Western diet is high in saturated fats, high in processed foods and sugars, which leads to basically clumping of red blood cells and the development of fat lining arteries of the body. This can be corrected, this narrowing of the arteries can be corrected using a vasodilator, a medication that causes blood vessels to relax. Or a lot of times what happens is somebody who has severe atherosclerosis can get an angioplasty, which is where they'll use like this little balloon to widen the blood vessels, like that, or surgical replacement of blood vessels. Sometimes they'll take a blood vessel from a cadaver and replace the damaged blood vessel. So here's a list of the principal arteries and veins of the body. What do you need to know? What I need you guys to understand and to remember, maybe for the exam, are going to be, of course, the aorta, right? The subclavian. The arch of the aorta is pretty common, right? We know the pulmonary circulation. You do need to know the left common carotid, but the left and the right common carotids. You know, the common carotid comes off of the aortic arch. Occipital, facial, all right. Of course, the coronary, because that's the coronary circulation, left and the right. You do need to know the brachiocephalic. So remember the brachiocephalic, circle that one, the subclavian, and the carotid does branch right and left. The carotid, these are all coming off of the aortic arch, all right? Of course, the descending aorta is very important because that's the large blood vessel right here, taking blood down through the body. The splenic feeds the spleen. The celiac feeds the digestive system. Renal, you've got to know, because that goes to the kidneys. When we talk about the renal system, that's going to become important. The mesenteric, excuse me, is important because it feeds the mesentery. The radial and the ulnar, you'll remember from taking blood pressure, if you took blood pressure. The iliac, external iliac. We don't need to focus on the femoral, popliteal, tibial, abdominal aorta, super important again because that's a part of the extension of the aorta coming down. It's just in your abdominal region. Superior mesenteric is just higher up. Common iliac, internal iliac. Here's your brachial again, up higher. Okay, brachial branches into the radial and the ulnar, and then the axillary is under your armpit. So all of these arteries have their vein counterparts. Okay, so if you know the arteries, you're pretty much going to know all the veins. I would say that you should, I'm not going to bug you about deep femoral. Don't worry about that one. But there is a femoral and then there's deep femoral. When you go to Merced College and you take Bio-16, the more, I guess you'd say, detailed anatomy course, you will need to know all of these because these are super, super important in taking blood to and away from organs of the body. Okay, I did want to include a picture showing you a partial blockage of an artery as a consequence of atherosclerosis.